Welcome everybody to an introduction to composting online training course. This should take us about an hour to work through the various information that we've got. So my name's Chris Purchase, I'm going to be the trainer today. But before we launch into the course, I'd like to hand over to Bradley Nolan from SPREP, who's just going to give you a bit of an overview around Pack Waste Plus and the background to this course. So over to you, Bradley.
Much appreciated, Chris, and good afternoon, everyone. Thank you so much for joining us, and for those of you who have had the pleasure of sitting in a face-to-face training with Chris on that. Good to see you back here, and hopefully you've brought some colleagues along. The beauty is, as Chris has mentioned, we are filming or recording today's presentation, so we will make sure this is available online for future reference. Just to let everyone know, I'm the program manager for the Pack Waste Plus program. It is European Union funded, and we've been going since late 2018. And unfortunately, we will be finishing up at the end of June this year. But the beauty of the investment from the European Union is that we've been able to put a lot of effort into the organic management space. And you'll be hearing a little bit from Chris and my colleague Hilary later on about why management of organic waste is so important. But the beauty of this work is that it couples with a significant amount of resources that will help you set up and maintain organic management systems, be it at community or household level, and the principles remain the same even as you scale up. This course that you'll be hearing today, and all of the materials that we talk about organic material. We don't talk about organic waste, because there is no such thing as waste in the organic space. This is one of the most purest circular economies that we do have. So we are really excited to be able to bring this training and all of the organic management resources to you. And please do reach out to either Hilary, myself, or any of our colleagues here at SPREP following the training with any questions or assistance requests that you may have. I wish you well today, and I look forward to connecting with you all as you go on to implement a lot of the tools and tricks that you'll be taught today. As I mentioned, my colleague Hilary will come on at the end of the training and just talk a little bit more about our project further. But in the interim, I will leave you in the very capable hands of Chris from Tonkin and Taylor. Thanks, Chris.
Fantastic. Thank you, Bradley, and welcome to the couple of additional people that have joined us. Looking forward to working through this material with you. And please feel free to raise your hand as we walk through the material, and we'll certainly have some time at the end of the training to address any questions that might come up as well. But I guess just as a little bit of context for why we're interested in this, Bradley's already alluded to the fact that organic materials make up a significant component of materials that are currently put into landfill at the moment, collected often and certainly put into landfill, but present a very interesting opportunity to not put those into landfill, but to generate products that are of significant value. So what we want to create today is some knowledge and some capability amongst the participants around how you might go about composting those materials, and that's certainly one possibility. Often there's also other possibilities, such as capturing some of the materials such as food waste for stock feed, those sorts of things, and maybe even things like anaerobic digestion in some cases. But the focus today is around composting. So I guess what we're talking about is taking these materials, might be vegetation, might be food waste, putting them through a composting process, which we'll spend a bit of time on defining, ultimately generating effectively something that looks a little bit like a very rich soil product that can be used for home gardening, could be used for larger scale market gardening as well. And I just want to underline that a lot of the photos and imagery that we're using through this training course today are from different parts of the Pacific region. So this picture up on the top here is of a simple little screening process for compost that is made in Majuro and the Marshall Islands. This picture here is market gardens in Rarotonga that so happened to take a whole lot of compost from one of the market gardeners who identified an opportunity to deal with both vegetation and a range of other materials making compost. And this image here is two things: a bag of soil and a bag of compost, and then comparative growing from that material again in the Marshall Islands. So this is not something that's theoretical. It's something that we can actually do here in the Pacific region and make a significant difference to. Oh, so I guess I just wanted to show you an example again of something. In this case, we're looking in Tuvalu. So in addition to doing this online training, we've been delivering face-to-face training in a number of locations across the Pacific region. This is the facility in Tuvalu. They've got a number of bays where they're shredding up vegetation and also mixing that with a number of other materials. You'll see some very similar things to these monitoring sheets. Not sure how many of you can speak or read Tuvaluan, but the concept should be pretty similar and pretty familiar to you by the time we're at the end of this sort of hour. But again, underlining the fact that what we're talking about here is something that is currently occurring and can certainly take place within your context with materials that are generated typically across the Pacific region. So some principles for effective composting. We're going to spend a little bit of time talking about definitions, talking about the different components and some of the science that underlies things. So please feel free to put up your hand and ask questions in the chat. I'll try and keep an eye on that as we go through the material. So first thing I want to do is make sure that when I'm using particular terminology that I'm actually, we're all understanding exactly the same thing. So we talk about organics or organic materials. So these are the things that might be in our waste stream. Typically they were once a living thing. So you might be talking about food that we don't want anymore. You might be talking about vegetation, things like twigs and things like that. You might have heard the term mulch. And when I use the term mulch, I'm normally thinking of particularly woody or garden material that's been shredded up. And that's a really useful product in the context of a garden or a market garden growing system or something like that, but it's not compost. So it's a very different thing. Often in a warm climate, that will dry out quite quickly, so it'll be quite a dry product. But what it can be quite useful for is retaining moisture. It captures moisture as it evaporates from the soil, and over a long period of time, that will break down into soil. Composting is a natural process where those organic materials, whether it be a mulch type product or things like food waste and so on, will break down and ultimately turn into something that looks suspiciously like a very, very rich soil. So composting produces a product called compost. And if you pick up mature compost and feel it, if you have a bit of a smell of it, it'll probably just smell like dirt. And that's a pretty good indicator that your compost has been right through the composting process. So a really important thing. The other thing to note is that if we left mulch or vegetation or food waste just sitting out in the forest, in the bush, underneath a tree, whatever, over an extended period of time, that will ultimately break down into soil. That's how soil is produced. So what we're trying to do with composting when we're actually managing it as a process is take advantage of that natural process and maybe make it work a little bit faster, maybe manage some of the risks around that in terms of, say, the food waste going smelly and things like that. So our job is to help nature rather than replace nature. And that's really worth having in mind as we work through this different material. So one way to think about composting is that there's a range of different things that need to be put together to enable that natural process to work effectively. It's a bit of an ecosystem. Depending on where you are, you may see worms in your compost. You'll certainly have a whole lot of microorganisms that are too small for us to see. But there's a range of different things that will happen as that composting process progresses that tells us that something's going on there, that there are bugs working. Some of those things tell us that it's working well. Some of those things will give us some clues around how we might actually need to change things, how they actually operate over time. So what are some of the materials that we might actually put into composting? That's a really important thing for us to consider. So if we think about what happens within the Pacific region, you can see a whole range of different materials there, anywhere from palm and flax to byproducts from fish processing or catching fish and getting those ready to eat, coffee byproduct, anything from coffee grounds to the leftovers from actually harvesting the coffee, things like the malts and so on from beer, whole range of different things. You can see all of those. And you might notice that we've colour coded those. So we've got some that are looking very brown, some that are looking green, some that are somewhere in between. And what we're trying to illustrate there is materials that are high carbon. Those are the ones that are coded brown. Materials that have a lot of nitrogen in them, a high proportion of nitrogen, are green. And then ones that are reasonably neutral between those two components are coloured. I guess that's kind of an off-white sort of colour. And you'll start to see why that's particularly important. And ultimately, when we're putting together a compost pile, one of the things we need to be thinking about is getting the right mix of food or the right conditions for the microorganisms to do their job. And that involves balancing carbon and nitrogen. So when we're looking for different materials, it's likely that we'll have a mix of these materials in the right mix for our context. Another thing to note here is that you will probably have some, but not all of these materials. So we'll have a bit of a conversation around how you might actually strike the balance or get the right carbon to nitrogen mix. But ultimately, you need to experiment with the materials that you have at your disposal. So we'll give you some clues, but ultimately it's up to you to figure out exactly how to run it in your context. So there's some guidance material. Again, we'll flag that later on. So let's just talk a little bit about what's going on in a composting pile. And I'm hoping that most of you have had some exposure to composting either in your home or at a larger scale within your jobs. Hope that'll be helpful for you as you start to see what's going on. But there's basically three things that we need to make sure are in balance for a composting process to work well. And earlier on, I talked about the fact that we're trying to help the microorganisms deliver on this for us to break materials down, convert organic materials into a compost. And these microorganisms are a little bit like us. They need air, they need a little bit of water, and they need the right sort of food. So our job is to make sure that there's enough air for the bugs to breathe, there's enough water to enable them to continue to operate, and the right mix of food. And what we will see is that if we actually get the food out of balance, if there's not enough water or too much water, if there's not enough oxygen, then things will get a little bit out of balance. And there's things that we can keep an eye on as the compost is happening that will tell us what is out of balance and then enable us to actually work on things. So with composting, we're trying to maintain what we call an aerobic process. So that means there's plenty of oxygen. So the bugs are a little bit like us. They like to breathe in oxygen. If there's not enough air, then the compost pile can go what we call anaerobic, or there's not enough oxygen going on. And one of the problems with anaerobic decomposition is that it can produce some pretty unpleasant odours. And the good reminder about this is if we think about other places where bugs are working in an anaerobic environment, one example of that is in our gut. And as they work in our gut, that's fine because you can't smell what's going on in your gut. But what we do know is that the byproduct from our digestion process and the microbial action within our stomach is what we drop into the toilet. And we know that that doesn't smell very nice. So that's a good clue as to what happens when things are going anaerobic within a composting pile. And you've probably come across a composting pile that smells a little bit rotten or a little bit unpleasant. That's a good indicator that there's not enough oxygen for the bugs that we want to be working to actually be operating well. Similarly with water, if we don't have enough water, we tend to slow down. If we don't have enough water, far too little water, then we might actually die. So these bugs are exactly the same. We talked about dry mulch before. That's an example of something that's too dry to actually break down very quickly at all. So that's why it takes so long to break down over time. And the mixture of food can have an impact on how quickly things break down, and we need to talk about this balance between carbon and nitrogen. So if we get the right input material, combination of vegetation, food, maybe other things like manures, coffee byproducts, a range of different things. We get the balance of air, water, and food about right, and we give it enough time. Ultimately, what we'll get out the back end is a compost product. That picture that we've got there is showing a product that's probably been through a screen. So often as you go through the composting process, it'll be a bit lumpy, but we'll get something that looks and smells a little bit like soil, a very, very rich soil. And as we saw from those photos from the Marshall Islands, if we try and grow things in that compost product, they will really like it because it gives it a good mixture of both nutrients, but the remaining microbes in that compost is also very good for the soil as well. So air, water, food, and the right amount of time, balancing those, will ultimately take the type of materials that we're seeing on the left-hand side here through to a compost product. Our job is to basically support the microbes as they do their work over time. Right. So let's talk a little bit about the carbon to nitrogen ratio. So as I said, there's some rules of thumb in terms of how we might actually balance the two different areas, but it's going to be a combination of the brown materials that you can see on the left-hand side there and high nitrogen materials on the right-hand side. You may or may not be able to see that all of these materials have some carbon and some nitrogen, but the brown ones have a much higher proportion of carbon sitting in them. So what happens when we have very, very high carbon material is that material will break down, but it will break down quite slowly. And there's certain bugs within the composting activity that prefer that type of material. If we have high nitrogen material, one way to think about it is that that's like a sugar hit for the composting pile. So the bugs will work very hard on that. And one of the challenges when we have a very high amount of nitrogen in our composting pile is that the bugs get very excited, work very, very hard. They breathe very, very hard, so they use up a lot of the oxygen. So what we can have if we have too much nitrogen is that they draw down the oxygen and the process goes anaerobic. And as I said earlier on, that can result in it starting to get a little bit smelly. And there's some things that we can do to fix that. But I guess that's the balance that we're trying to strike between these two components. So it's a pretty good chance that you'll have access to things like coconut husks, woody material. Hopefully you'll have access to something like a shredder that can chop that material up. You may have access to things like sawdust. You can use paper and card if it's shredded up, but you need to be careful that you don't use too much of it because it can actually compact down and make it difficult for the air to flow. You'll probably have access to some of these high nitrogen materials as well. Things like fish waste, food organics, some of the byproducts from beer manufacturing, things like animal manure. Just remember that a lot of those materials will have some risk associated with them. So we just need to be a little bit mindful of how we manage looking after those materials. We need to do things like making sure we're washing our hands very carefully after we've been working on the composting pile, those sorts of things. So the ideal carbon to nitrogen ratio. So the ideal ratio between those two is about 30:1. But remember, all of these materials have some carbon and all of these materials have some nitrogen. So a pretty good rule of thumb is if we go with about 3 to 4 parts of carbon-rich materials and maybe 1 part of nitrogen-rich materials very, very carefully mixed up, is a good way to actually think about actually starting. And then you can actually monitor your pile and see whether you're actually getting odour, whether there's any indicators of the pile not actually working properly or not. Me for a moment while I just check. There we go. Cool. So the key thing here is experimentation and using some of the things we're going to talk about in a moment around monitoring how well your pile is working to determine the right mix of the materials that you have at your disposal. So monitoring reporting is really, really critical. How do we actually understand what is going on within our system? And The picture here is showing someone that's in Rarotonga, I'm pretty sure. It's an electronic temperature gauge. So temperature is a really useful piece of information. And it's really easy to fall into the trap of thinking that we need complex instruments, particular specific tools. But one of the things I like to think about is actually we've got some really good tools at our disposal, all of us. So we can look at what's going on with the composting pile, use our eyes and make some assessments. We can use our nose to figure out, is there an odour going on here? What's going on? What might that be telling me? And we can also use our hands to feel what's going on within the composting pile. So yes, it's useful to have some monitoring tools, but make sure that you make use of the tools that you have at your disposal in terms of your own senses. The other thing that I was discussing with Simon Millie earlier on today, and have also discussed with a number of people with the face-to-face trainings, is we can use things as simple as a shovel or a machete pushed into the middle of a pile to get a bit of a sense for what's going on from a temperature perspective. So a temperature gauge, super useful, but actually we can also make do with what's available to us at our fingertips wherever we might happen to be operating. So a few things we might be doing once we've got a composting pile up and running. From an air perspective, we can take a look at what's going on to see whether we've got the right mix of materials that might actually allow materials to flow through. We might use our nose to figure out whether there's any odour coming on. If we are smelling a rotten odour or an unpleasant odour, that might indicate that we've got an insufficient airflow. So we might need to adjust the mix, add some things like wood chips and so on to help with airflow. We might simply need to do some mixing with a shovel or with a digger or whatever we might have at our disposal. It might also indicate that we've got too much nitrogen-rich material within that pile, and we need to add some more carbon-rich materials just to get the balance right, so that we're not using up too much of the materials, too much of the oxygen too quickly. From a water perspective, we should be able to see initially whether the compost is too wet or not, but we can pick that up and give it a bit of a squeeze to feel like whether there's too much water in there. We talk about the squeeze test, where if you simply pick up a handful of compost, if you squeeze that compost and it holds together okay, feels damp, that's probably a pretty good indicator we're in about the right sort of region. If we squeeze that compost and there's water dripping out, that's a pretty good indicator it's too wet. If we squeeze it and we open our hand up again and it falls apart, that's probably a pretty good indicator that it's too dry. Water content and retaining the right amount of water is one of the significant challenges with the high temperatures that we get across the region. Too much water can restrict airflow and cause the composting to go anaerobic and become very, very smelly. Similar questions around food. If we've got too much nitrogen, that might actually drive a smelly thing, an ammonia-like smell. So that's a pretty good indicator just by smelling. Too much carbon might actually keep things a little bit dry, keep things very, very slow composting as well. Right. So this has probably talked through some of the stuff that I've already walked us through. Making use of your eyes, making use of your hands, doing a bit of a temperature check and smelling. So I mentioned earlier on that if we've got a temperature probe, that's very, very helpful. And we can start to measure against different guidance areas in terms of temperature. But in the work that we were doing to try and get things underway in Papua New Guinea, we simply used a machete. And we put that into the middle of the pile, left it there for about 30 seconds or a minute, and then pulled it out and put our hand on it. Pretty good indicator. If it's feeling cool, then that's probably cooler than we want it to be. If we put our hand on it, we go, gosh, that's feeling pretty hot, but we can keep our head on it. That's starting to get up around that 130 plus Fahrenheit or about 40, 45 degrees centigrade. That's probably okay. If we put our hand on that machete and we have to take it away because it's too hot, that's probably getting up over 55 degrees. And that's the sort of numbers that we're hoping to get to at a particular stage. So temperature is a very, very important part of the overall mix. One of the people we talked to in Papua New Guinea actually talked about using a wooden stick and pushing that into the middle of the pile and leaving that for a couple of minutes and then pulling it out. Gives you a bit of an indicator of temperature as well. So it's all about working with the tools and the information that we've got at our fingertips to figure out what's going on. So if we put our hand in there and we feel like it's a little bit dry and crispy, we might even be able to see that just from looking, then we probably want to be thinking about adding some water, and it may be that we need to add some nitrogen-rich materials to help that keep moving. For example, if we put our machete in there, or we did our temperature measurement and found out that it was getting very, very hot, there's a couple of things that we might do. We might need to actually just turn the pile to cool it down a little bit. We might want to add a little bit of water if it's also a little bit dry. We might need to add some carbon in there just to slow things down a little bit. And one of the risks that we've got with that heat component, particularly where it's drying out and getting quite hot, is there are examples of compost piles actually catching on fire, spontaneous combustion, and clearly that's something that we don't want to happen. We might have a scenario where the odour is telling us that it's not great, but what we're looking for is that the composting, as it's going through its composting process, should be feeling earthy, smelling earthy. That's a pretty good indicator. I think we all know what rotten vegetation smells like, and that's an indicator that we need more oxygen, potentially some additional carbon, to make sure that things are working well. So I want to talk a little bit about temperature, because I've kind of alluded to it a couple of times. And what goes on when we actually set up our composting pile, very, very quickly, what we will see, if we've got the temperature right, the mixture of food right, so the carbon-nitrogen mix right, we've got the right level of moisture, and we've set up our pile, is that very quickly the composting activity will start to create heat, and that's just a reflection of those bugs working really, really hard. But what we will see is a bit of a temperature difference from the middle of the pile right out to the outside. So around the outside of the pile, it's going to be pretty much at temperature that we would expect in the surrounding area or soil or things like that. It might be a little bit higher, so around that sort of 30, 35 degrees mark. But what we want to see is the middle of that pile actually getting up to that 55 or higher sort of temperature mark in the early stages of composting. And if we get up to that level, that will kill a lot of the bugs that we might be concerned about that might make us sick. If we're talking about things like manures and so on, it will also kill a lot of weed seeds. So we're certainly hoping to get to that level. But if we don't mix things up, then only the centre of the pile will get to that level. So that's one of the reasons, as we go through the composting process over time, why we want to mix the compost regularly. So that the material in the middle that's got up to a high temperature goes out onto the outside of the pile, and the material that's been at a lower temperature then gets to sit in the middle for a while, and again we will see that temperature go up over time. And what we're showing here in these bottom photos is someone doing that simple squeeze test, so squeezing material together, and then, as I said, if you squeeze that material and then open your hand up and the material holds together well, is feeling damp, it's pretty much where we want it to be from a moisture content perspective. If we squeeze that material and we had water dripping out, that's an indicator that it's probably a little bit too damp. If we opened up our hand and the material fell apart, that's a pretty good indicator that things are looking a bit too dry, and we might need to look at ways to add water to that. So this is a graph of temperature over time, and I'm going to spend a bit of time walking through this. So there's some reasonably complex words in here, but we'll just work our way through. So when we set up a pile, we've got the right mix of carbon to nitrogen, we've got the right level of water in there, we've given it a good mix up, and it's underway. What we will see is that over time, and often quite rapidly, the temperature will go up. So pretty quickly it'll get up to around 40 degrees, and there's a certain community of microorganisms who are quite happy at that phase, but once it gets over about 40 degrees, a new bunch of microorganisms, they're called thermophilic, which means that they like the high temperatures, will kick in, and they will take the temperature potentially as high as in the over 60 degrees, and that's pretty hot. So if you have put your machete into there, left it for 30 seconds, pull it out, you'll be very unlikely to be able to hold on to that machete without wanting to take your hand off. So this process is really important because, as I said, it kills some of the pathogenic or the dangerous bugs that might be in there, and it also can kill a number of different weed seeds. So if we've got the conditions right with food, with plenty of oxygen, with the right amount of water, then we'll get high temperature, and that will eventually, over time, that will start to come back down again, which is one of the reasons we want to keep an eye on temperature over time. And then ultimately, the temperature will start to drop down again. And once we get back down to around that 40 degrees, the mesophilic, or the bugs that started off for us, will kick back in, and the temperature will drop again over quite an extended period of time. Now, this period in here where it's cooling down, where your compost is cooling down, is actually a really important part of the process. If we just pulled the compost out here, the problem we have is that there's some of the breakdown hasn't completed, and some of the products of the work that these thermophilic bacteria produce that are still sitting within the compost can be toxic to some materials. So we have high levels of some toxic materials. And we had a situation in one of the projects that I was working on where we pulled out compost too early, and there was some growth trials done with those early stage compost products, and it actually killed some plants. So we need to be very careful about allowing compost to cool down completely, right down to basically temperatures that we're seeing in general soils, and allowing that material to be stable, cool, and then we've got effectively a very rich soil. And one of the ways to check on that is actually to do growth trials, plant some fast-growing plants into samples of your compost and see how they grow over the space of a few weeks. So this sort of period here, the period of time that you might be in this high temperature phase depends on how well you've got that mix right. So if you're struggling to get up to above 60, then it probably means that this phase will take much longer. So we do want those temperatures to get quite high, and we do want to be monitoring both that rise and lowering. The other thing that's worth noting is because we want to be mixing our compost, as I said earlier on, we've got this pile here where we want to take this material in the middle and put it on the outside and put stuff into the middle. So a real world compost pile, we will see the temperature going up, and then as we mix, the temperature will drop down a little bit and then we'll go up again. So it's not a beautiful curve like this is shown in theory. It'll be a bit of a jagged line going over time. So from a monitoring and reporting perspective, it's that once we've got the compost pile set up, it's really important that we keep an eye on it. So I would suggest certainly in those early stages we were going through, seeing the temperatures go up. This is where most of the activity is going to be really actively happening. We should be looking every few days, going in and checking on the water content, checking on the whether there's any odours going on, checking to make sure we're comfortable with where the content looks like. So this is all about your eyes, your hands, your nose, and potentially a temperature probe or something like a machete or a shovel to check on what the temperatures are looking like. And ideally, I showed you those monitoring templates before, we should be actually recording what's going on every few days so that we've got a record of what's going on. And as we're working on adjusting our carbon and nitrogen ratio, looking at different mixes of materials, that recording of how things are working is very useful for us to refine our batches over time, add different materials and understand what's going on. Cool. So this is a bit of a detailed table, and it'll be useful for you to pick up and look at in more detail once we've completed the project, completed the training. But this is just a bit of guidance, I guess, in terms of how we might actually go about troubleshooting what's going on. So from a look perspective, we're wanting to look and make sure that we've got the right mix of large and small materials so that air can actually flow within the composting mass, that we're not getting clumps of materials. We want to see if it's looking a little bit too soggy or if it's looking too dry. And one of the things that can also be an indicator of things going anaerobic, or the balance not being quite right, is the material can look quite slimy. So if you've done composting at home, you've probably been in a situation previously where you've dug into your composting pile and you've come across quite a slimy sort of area. That's a good indicator that things have gone a little bit anaerobic. We've talked a lot about that squeeze test in terms of feeling how things are working. You can also use your hand a little bit as a way of getting a bit of a sense for what the temperature looks like in terms of the centre of the pile. So you might dig a hole into the pile and just have a bit of a feel for how the heat's feeling. But this idea of inserting a machete or a shovel if you don't have a temperature probe is really, really useful way of figuring out how things are working. That depends obviously on the scale of the compost pile that you're looking at. Your nose is a very, very important tool. So we're looking for bad smells versus that earthy smell as an indicator of what we might actually think about doing in terms of adjusting things. I might pause there for a moment and see if there's any questions. Feel free to put your hand up or unmute and jump in, or drop questions into the chat. Keep an eye on that chat. So as I say, feel free to jump in and ask any questions if you do have them. So I talked quite a bit about monitoring and reporting. So this is an example here in the middle of a simple little reporting sheet. And that sheet, often we would look to go with a batch. So we would record and update that over time. And that's prompting us to do exactly this sort of look, feel and smell activity. What is that telling us when we're checking every few days or every week or so? So that's a really useful way to capture information, but also record that so we can learn lessons as we adjust our batches. One of the things we did in Tuvalu was we put together quite a large notice board. So this is probably a metre by a couple of metres. And the intent of that is to enable you to record key insights for others who might be working in your facility. So if you're setting up a community composting facility that lots of members of the community might be involved with or something like that, having a simple notice board where you can pass on messages to other people. And the other thing we've done there is highlighted some of the things we need to think about from a safety perspective and regular checks and so on that might actually be useful for people to think about. So it's a good reminder of what's going on. So the sort of things we might do is obviously those air, food and water checks. We might have a bit of a check for contaminants, so things like plastics or plants that we don't want to go into the mix. If you're a larger facility and you're accepting materials from the general public, you might want to look at the incoming materials and have a bit of a look at what's being dropped off. Are there any noxious weeds that you don't want to go into your process? Is there things like plastics that we certainly don't want to be in the compost because that'll just contaminate your product? Things like rocks and so on, particularly if you're going to be putting those materials coming through a shredder. Rocks and shredders don't combine very well at all. This little is just another example of a recording of temperature that someone's put together, and as you can see, there's a little bit of unders and overs moving up and down as you go into that high temperature phase, and then the temperature starts to drop down as the process continues. And it's this very long tail that I just want to underline again, making sure that you let the compost come back to pretty much to ambient temperature, the sort of temperature of soil around your area, whether that's 25, 30 degrees in that sort of order. If it's higher than that, that's a pretty good indicator that there's still some activity going on. So you need to be quite careful that you are checking temperature, but also using things like that, the nose check. What is it smelling like, to give you an indicator of whether you've got a mature product or not. So I guess just a couple of images of compost piles that might not be going perfectly, and maybe this is an opportunity for people to pop some comments into the chat if you feel like doing a quick type. This is a composting material that actually isn't going too well. Any thoughts around what might be going on here and what we might need to think about to actually improve it? There's always the danger of asking a question on a Zoom meeting. Anyone brave enough to provide some suggestions around what might be going on here? Do you think clearly it's not going very well? Well, I'll fill in the gaps then. So I think what we're seeing here visually is something that clearly looks very, very wet. So what that means is that it's very hard for oxygen to come through there. What we're trying to show here with the imagery here is that it's probably not smelling great, and you can kind of sense that even just from looking at the imagery. So that probably suggests to us that it's gone a little bit anaerobic. So there's a few things that we could do that might make a difference here. Any thoughts really quickly before I jump in with some ideas? Take that as a no then. So, yep, add more carbon materials. That's a really, really good idea. Absolutely. And chances are those carbon materials will be larger pieces. So things like chipped timber, chipped wood. So if we mix those up, that would add carbon, but it would also help the air to flow through as well. Yeah, excellent answer. Thank you. Cool. Okay, so I think I've got another example here of something that doesn't look quite right. Any ideas about what the problem is with these images? Trying to make compost with this material. Any thoughts? Feel free to drop a note into the chat or speak up. So remember, we're thinking about, have we got the right food mix? Have we got the right moisture, right amount of water, and is there enough air flowing? So if I look at this, the nature of the material, it looks to me like air can probably flow okay there. So that's probably okay. There's a little bit of green or nitrogen-rich material there. So the carbon-nitrogen mix looks like it might be a little bit too much carbon. So that could be an issue. We might want to throw a little bit of nitrogen-rich material in there. Typically, nitrogen-rich material also has quite a bit of moisture, which is a good thing, because if I look at those photos, I think that looks pretty dry. So we'd certainly want to be adding some water, and we'd probably be wanting to look for some nitrogen-rich material. So that could be some green vegetation, it could be some chopped up food waste, those types of things. Hopefully that makes sense. So let's look at the third one. This one's a little bit of a open for interpretation, but what do you think might be going on here? So again, if we think about air, they don't look too bad, those two piles, in terms of the ability for air to flow. So that's okay. In terms of water, they look a little bit dry. You could probably add some more water there to get that working a little bit better, but probably not too bad. But similar to the last one, they look like there's a lot of kind of carbon-rich materials there. So if it was me coming across this and wanting to get it working a little bit better, I'd probably be looking to find some nitrogen-rich materials, and I'd probably be wanting to add a little bit of water into that. I'd hazard a guess that that's probably not smelling too bad, although you might find right in the middle of that pile, if you dug it right up, there might be some wet kind of anaerobic areas in the middle. So hopefully that all makes sense. But this is the sort of process that you need to go through, is actually understanding I need to make sure the air flow is right. There's oxygen for the bugs to do their work. I need to make sure that they've got the right mix of food, carbon and nitrogen. Have I got the right mix going on? And I've got to make sure there's enough water, but not too much water, to allow air to flow, to allow the bugs to actually have the water that they need to do their thing, to break this material down into compost. So similar process for all three, ask those questions and then figure out what different options might be to move forward. So the tricky thing here is that it's not always a simple answer. There might be a couple of things that you need to do. So I'm really keen for you to be thinking about that food, air and water. What are you seeing? What are you feeling when you actually interact or pick up the material, and what is your nose telling you? And what might the temperature be telling you? So I want to spend a little bit of time now just talking about how you might actually go about managing your facility, because when we pull together a whole lot of organic materials and start to try and process them, enable them to compost down a little bit faster than if we just left them to their own devices, things can go a little bit wrong, particularly if we've got a lot of materials. It can get smelly, we can attract rodents, those sorts of things. So what are some of the risks that we need to consider? Whether it's a community compost that we're setting up within a village environment, or it's a larger scale facility servicing a much larger community. So we've got a few slides here. Again, there's a lot of information on these slides. We just need to make sure, you need to make sure that you've gone through and looked through this as you go about setting up your facility or thinking about managing your facility. So weather's obviously a significant one. Heavy rain can saturate your compost if you're not too careful. So covering it can be quite a useful context, or making sure that you've got a lot of dry materials in there to manage that moisture. The biggest challenge we're seeing right across the region is actually managing the heat and making sure that you maintain a decent moisture level. So covering's useful, having access to things like roof water and so on to add moisture to make sure things aren't drying out too much. In a lot of cases, we're using things like tarpaulins or even just large pieces of cardboard to try and cover the compost and retain some of the moisture. Contamination's a really important issue. So you manage most of that with the materials coming into your process. So before you actually set up your compost pile, removing plastics, managing things like rocks and soil, things like glass and so on. So those are reasonably easy to spot, and it's worth putting in the effort up front. But we do need to think about things like vegetation that might be contaminated by pesticides. So making sure you've got a good understanding of where your materials are coming from. As compost breaks down, it can actually create high-strength organic materials that contaminate surface water. So if we've got runoff from rain and so on, we need to think a little bit carefully around how we manage that runoff to make sure it's not going into waterways or contaminating drinking water, those sorts of things. We also need to think quite carefully around some of the materials that might actually contaminate land, whether it's around physical contaminants like plastics and so on, or some of those pesticides and so on. In terms of the materials that are coming in, we need to be quite thoughtful around some of the weed materials that people might bring to our composting facility. So in some cases, provided we're getting those high temperatures, we will kill weed seeds. But in some cases, we need to be just actually removing weeds that are not suitable for composting. So if I think about in the context that I live in, and here in New Zealand, we have a weed called gorse, which is a prickly plant. It's actually, the seeds are designed to be stimulated and ready for rejuvenation or germination as a result of fires. So they're used to dealing with very high temperatures. So gorse seeds will love going through a composting process and be very happy to be sitting within a beautiful compost product to start to grow as soon as they're underway. So we certainly don't want to be putting gorse through a composting process. So there will be similar materials like that. So understanding particularly weeds that you're trying to get rid of and making sure that you manage those. And then there's things like harmful pathogens to humans. So if we're thinking about something like manures, we need to be mixing those very carefully, washing our hands and so on, but also making sure if we are introducing manures to our composting process, that we're getting to very high temperatures for an extended period of time to kill pathogens. Overall, just managing the cleanliness and layout of your facility. If you are introducing things like food waste, you want to make sure that those are introduced into the composting process and up to temperature very quickly, to avoid things like rats getting very interested in getting involved in your composting pile. If you're sitting at 55-65 degrees, most vermin won't be very interested. If you're much lower temperatures, then they'll be happy to climb in and enjoy the nice warm environment, but also to get stuck into some of the food waste and so on. So managing your process very carefully to deal with that is very important. If you're shredding materials, if you're mixing materials around, you also run the risk of creating odour and dust and noise and so on. So managing that very carefully in terms of your neighbours. Again, if you're in a community scale compost within a village, you need to think quite carefully around where you're located for when you're turning materials where there may be some odour, those types of things. If you're using machinery, clearly that creates some risk, both for people who are operating on the site, but if there's very easy access. Things like shredders are designed to chop up often quite significant pieces of wood and so on. So it doesn't take much imagination to imagine what that might do to someone's finger or hand if they were inadvertently captured within the shredder. So being very, very careful, keeping people away, looking out for materials that might be flicked out of machinery, but also moving around vehicles and things like that. I mentioned earlier on that composting piles can get very, very hot very quickly, particularly if they dry out as they heat up. We can get to a situation where compost piles actually catch on fire. So this is very, very important to manage. It's why we need to keep an eye on temperature and understand what's going on and what our options might be for actually managing with that. Also, if we have dry materials, just a spark ignition from equipment and so on can actually create fire as well. So having the ability to access water, having plans in place to deal with fire if it occurs, particularly for larger scale composting facilities, very, very important. And ideally, particularly for larger scale facilities, we need to be thinking about managing site access and so on. So I think I might be about to hand over to you, Hilary, just to talk us through some of the facilities. I think I may need to do the flicking through of the slides for you. So over to you, Hilary. Or maybe before we do that, Hilary, we should just pause a moment and see if there's any other questions or thoughts or comments from the floor. Joyce, I saw you noting it'd be great to have a copy of the presentation. Absolutely, and we've also recorded this presentation, so it'll be available on the SPREP website, I understand. So any questions, thoughts or comments before we get Hilary just to underline some of the resources that are available? Doesn't look like it, Hilary, for now. So maybe if you fire away and instruct me how to move through the slides.
Thanks, Chris. And thanks for condensing a 1.5 day training into 60 minutes there. You did well. And I think the team on the line here will realise that there's a lot of information. Chris has zoomed through it, hopefully providing a bit of inspiration for what's possible and to get you started. So I thought I'd just take a few quick minutes here just to provide an overview of what information is there to assist on the what's next. So I'll introduce some of the resources and really how they link together. These are all available on the PackBase Plus website in no particular order, but there is a bit of a family. So firstly, there's a decision support tool, which runs through these 9 questions, and a lot of these were what Chris went through. Some simple questions, and there's just drop-down answers, so not super complicated. Just understanding a little bit about what sort of throughput you've got in terms of volume. Is it a couple of wheelbarrows a day or a couple of dump trucks a day? What some of those carbon and nitrogen ratios you might have? What's the budget available? The water? Some of these sort of key questions that were reflected in the session now. Once you've answered the 9 questions, if you just flip forward through once, Chris, the system will give you a list that's pretty budgeted, pretty basic. It's not super complicated, but it will list what the sort of composting systems that might be applicable to your site, given your budget, your throughput, your climate, etc. And so then if you flip through once more, Chris, from there you can see maybe the top 3 options to consider. And these are based on a lot of research that we've done around the Pacific, understanding that there are sort of 8 composting systems that are seeming to work pretty well here. Some of them are animal feed. If you've got just a lot of nitrogen materials from a market, maybe it's not composting at all. The key is getting it out of the landform, looking at it as a resource, not a waste. Perhaps it's going straight to a pig farmer or the chicken farmers. Similarly, if you've got a lot of carbon material and not much of the nitrogen, maybe it's just mulching it up, turning into mulch, and that's a resource you can use for landscaping and pig pen layering. So not all, we've talked a lot about composting today, but organics management, there are ways of considering other options to get this resource out of the landfill where it gets smelly and stinky and causes methane and causes flies. Getting it somewhere valuable, that's the whole idea. So basically, once you've gone through the decision support tool, you'll get maybe your top or the ranked order of what to consider. There's 8 accompanying fact sheets that you can then go to for some more reading. So in there's maybe 5 or 6 pages on each one. just providing a bit more information on if that's an option for your site. From there, maybe you've narrowed it down to one option. If you flick through it once more, Chris. Then on the website, there are links to editable design drawings. We don't have these in all 8, but the 3 key ones, these sort of community scale, bay composting, windrow composting, and aerated static piles. These are the general systems that we're finding is working pretty well in the Pacific. So these are just Excel drawings. They're all very editable. You can pick up and drop off the different links and this sort of thing. The idea of these drawings is it gives you a starting point that you can sketch something that you think might work on your Pacific site with the different land availability and this sort of thing, to get it to a point that you can then give it to a proper designer who can draw it up to get the building work. So it's just a starting point, understanding how big the concrete pad might need to be, how, where the water tank might go, these sort of things, just as prompts to consider. So from there, if you jump forward to the next page, Chris. From there, so that's sort of the facility design and construction. And then there's a couple of resources to help with the operation. There's one framework operation plan here for operating a bay compost system, which is a common one we see. There will be 3 more in that family coming this month. There'll be a framework operation plan for windrow composting, aerated static pile, and a more community, just a small community system. These are just, again, to get it started. They'll just be a draft A that you then go through, copy and paste what you think is relevant to your site, and there'll be prompts for how to fill it in to make it a valuable resource. Accompanying all that, there are these 2 technical documents. The handbook in particular, the one on the left there, goes through all the common organic materials we have in the Pacific. There's lots of technical composting guides all around the world, but not all around the world has our coconut fronds that are particularly high in very strong and high, hard to shred and this sort of thing. So how to compost those materials. We have more fish processing products than others. We've got noni and cocoa and other items that aren't really that common. So it's going through those common organic materials we have in the Pacific and giving some ideas. If you've got a lot of fish processing material, what can you mix that with? What sort of ratios might be a starting point to get that going? And also there's this Pacific standards for once you are looking at designing a facility, some options to consider in terms of ensuring that environmental and health and safety factors are considered. Jump forward once more, if you may, Chris. So that's sort of the technical resources. Then we've got a couple that will come up in a second. We've got a couple more household specific or community. The one top left there is a bit of a technical looking document, but really it's aimed at a community. If you've got maybe 50 or 100 households together, what might that system look like? How do you understand what's possible? Some opportunities to get started. And then one that's more targeted at households. So it's quite a colourful, not a technical looking document at all, summarising a lot of this information. So that's more targeted at the household. So perhaps that's a link that can go on your Facebook pages if people want to look at the more household level. Coming up soon too is going to be an online Moodle course going through a lot of information Chris has done here in the Moodle environment. And there's one case study already from the Cook Islands, and there'll be a couple more case studies coming up as well, just from some of the other Pathways Plus projects. So that's a summary on the what's available at the moment. I'm here, and Simon, Millie and Bradley and the rest of the Pathways Plus team are here. So do feel free to reach out if you want any targeted assistance or some more ideas of what the resources contain to get you started. But I'll throw it back to Chris, and I'm sure there's going to be option for questions and answers. So feel free to talk to us then. Cheers, Chris. Back to you.
Thanks, Harry. So I think what I'm going to do now is stop recording, and then we can, because there's not much point in having our question and answers conversation sitting on the website. But yeah, thank you very much for participating, and I'll put that last slide up so we've at least got that on the recording. Yeah, and how do I stop it?